Okay, so in Chapter 6, we're going to move from working with one equation to working with systems of equations. And systems of equations are a grouping of two or more equations. So we are going to solve those equations by graphing and by using algebra. First, we're going to solve systems by graphing. We're going to solve systems of two equations. So we're going to check the solutions of systems of linear equations and solve systems by graphing. We are also going to use those systems to solve real-life problems. So in example 1, we are going to solve a system by graphing. So in part A of example 1, we are going to graph these two equations. These two equations for part A are in slope-intercept form. So it's important to know for the first equation, the slope is 1, the y-intercept is 2. So to graph that, I graph the y-intercept and I count the slope. And I'm marking each point just to make it easier for me to draw a straighter line. Okay? So that's the first equation. Second equation has a slope of 3 and a y-intercept of -2. So I'm going to graph the y-intercept of -2, and I'm going to count the slope of 3 as going up 1, 2, 3, right 1. Up 3, right 1. And we should see by marking off our slopes that we found the solution to this system of equations. The solution to this system is the point 2, 4. That's what I would expect you to give me as an answer for the solution to that system. To check that solution, you could substitute 2 and 4 back in, 2 for the x value, 4 for the y value. If you do that to the first equation becomes 4 equals 2 plus 2, which is 4. That is true. In the second equation, if I substitute y for 4, it's 4 equals 3 times 2 minus 2, which is 6 minus 2, which both of these check out. So that's how we check our solutions for these systems of equations. In part B, we have a couple different types of equations. The first equation is in that standard form that we covered recently. So I would graph that by finding the x and y intercepts of that graph, or of that equation. So the x-intercept is going to be the x value when y is 0. So the x-intercept is going to be 2. Because if I substitute 0 for y, it's 3x minus 0. So my x-intercept is 2. My y-intercept is the y value when x is 0. So the equation is going to be -2y equals 6. So my y-intercept is -3. So my equation crosses the x-axis at 2 and the y-axis at -3. So I am going to graph that equation. In the second equation, really we're only given the y-intercept, which is -3, and that's going to be a horizontal line. So remembering that that is a horizontal line at y equals -3. So we should be able to see that our solution to this equation is the point 0, -3. Oops. 0, -3. And checking your solutions is just a good way to justify that you did the problem correctly. Now, I am not going to go through the guided practice with you. You can if you want to, but I was thinking of going through the guided practice when I'm back in class to clear up any misconceptions you have or any questions you have. So you can skip the guided practice for now. I'm going to move to example 2 because example 2 has us use a system or write a system and then solve that system using graphing. So in this example, scientists studied the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount? So the thing here is we have an initial weight, we have a starting value, and we have a growth rate. So we essentially have a y-intercept and a slope. So we can write these equations in that y equals mx plus b form. So for alligator 1, the slope and y-intercept, the slope is 1.5, the rate of change is 1.5 pounds per month, the initial weight, the y-intercept, is 4 pounds. So my equation is 1.5x plus 4. That represents the growth of alligator 1. Alligator 2 has a growth rate of 1 pound per month, has a starting weight or a starting value or a y-intercept of 6. So that equation is y equals 1x, or just x, plus 6. So this takes us back to graphing slope-intercept form. I'll do alligator 1 first in green. The y-intercept is 4. Put my y-intercept at 4. And my slope is 1.5, which is kind of weird. You go up 1.5 and write 4. I think it's easier to think of slopes as fractions. And if you think of 1.5 as a fraction, that's really 3 over 2. So the way I would count the slope from 4, I would go up 3, right 2, which would have me go up to 7 and right to 2. So that would be about right here, which is a little goofy. But if we keep going, go up 3 again and right 2 again, that would take me up to 10 and over to 4 as my x value. I go up 3 again, that takes me up to 13 and over to 6. I go up 3 again, that takes me up to 16 and over to 8. So counting that slope, I think it's really important to count that slope and draw as many points as you can to draw as straight of a line as you can. Now the next alligator is a little bit easier to graph. We start with a weight of 6, and that has a growth rate of 1 pound per month. So if you think of 1 pound per month, that's really like 2 pounds every 2 months. But I'm going to go up from 6 to 7 and over 1, up from 7 to 8 and over 1, up from 8 to 9 and over 1, and up to 10 and over 1. So my intersection point is the point 4, 10. So what that means in the context of this problem is that at 4 months, both alligators are 10 pounds, 10 lbs, okay, 10 pounds. So finding out that intersection point, and I'll finish drawing my line, but essentially that's how we figure out where two things have the same value. And we're going to use this in other applications later on. So again, I'm going to save the guided practice for next time. I'm just going to go through example 3 and the guided practice as well. You can skip that for now. We can come back to that later. But I just want to get through these so that we can be able to solve some of these equations with different types of solutions. So in example 3, we're going to find equations that have infinitely many or no solutions. Now in A is a good one because it has both types of equations, standard form and slope-intercept. So as far as the standard form goes, I can solve or figure out what the y-intercept is, or the x-intercept is, by finding the value of x when y is 0. So the x-intercept is going to be negative x equals 2. My x-intercept will be negative 2. And I know it's kind of goofy because it's y then x, but I usually find the x-intercept first. The y-intercept is going to be the y value when x is 0, so 2y equals 2, so my y-intercept is 1. So my x-intercept is 2, my y-intercept is 1. And if you think about slope, you can see that it has a slope of 1 over 2. So I go up 1, right 2 to count this slope. Down 1, left 2. So my line looks like this. Okay. And then if I graph the other equation in standard form, in slope-intercept form, I'll do that in yellow. It has a y-intercept of 1, so it has the same slope. And I count a slope of up 1, right 2, up 1, right 2, up 1, right 2. And you should notice that these lines, we call this coincide. These lines coincide. This type of system has infinitely many solutions. And, infinitely many solutions, not infinitely many solution. So two lines that are identical. These lines are identical. They share all their solutions. So these types of lines have the same y-intercept and slope. On the other hand, we're going to find a pair of equations that have no solutions. So in this next equation, both slope-intercept, First equation has a y-intercept of 2 and a slope of 2. So I go up 2, right 1, up 2, right 1. And I can go down 2, left 1, just to finish this out, to keep this as straight as possible. And that wasn't great, but you get the idea. In the second equation, y-intercept of negative 1, and I go up 2, right 1, up 2, right 1, up 2, right 1. And if we notice, these lines are parallel, which means they will never intersect, which means they will never have a solution, a common solution, because the point of intersection is where we find the solution to a system of equations. So this particular system has no solutions. And a way you can figure out whether two equations have no solutions, even if you don't see them on a graph, you can see that they have the same slope, but they have different y-intercepts. So that's an important thing. And you look at B, the first equation has a slope of 2, the second equation has a slope of 2, but their y-intercepts are different. So that means they cross the y-axis at 2 different points, but they have the same slope, so they will never intersect. So what I'd like you to do next is go on to the online activity. That's most likely going to be your choice between a quizzes or a GIMP kit, and you choose whichever one you want to do, but I want you to do one of those. And then after that, work through the practice and the checkpoint.